webinar. The topic of this webinar is knowledge graphs for enterprise data management. My name is Yasen Stoikov, and I'm part of the Ontotext marketing team and will be the moderator today. Joining me here are Jared McGuinness and Atanas Kyriakov, who will be the main speakers today. A few words about them. Jared is a managing consultant in semantic technologies. He previously was the head of research and semantic technologies at the Press Association. He investigated the role of technologies such as the natural language processing, the linked data in the news industry. Dr. McGuinness received his PhD in informatics from the University of Edinburgh in 2006. As said, joining him is Atanas Kyriakov. He is a founder and CEO of Ontotext. He obtained his master's science degree in AI from the Sofia University in 1995. He is also a top expert in semantic graph databases, reasoning, knowledge graphs, semantic tagging, linking, and search. He's also an author of signature academic publications with more than 3,000 citations. Before moving on to the actual part of this webinar, I'd like to quickly go over a few organizational details that I think are important. First of all, this webinar is being recorded, and a link to the recording will be sent to you over a follow-up email in a couple of days, so you can watch it and rewatch it at your own convenience. Currently, all of you are muted, and this is mainly to avoid background noises, but also to enable the speakers to present without any interruptions. You can still communicate with us via the question box in your GoToWebinar panel, and we have planned a short Q&A session at the end of this webinar in which we will try to cover all of your questions. In case we don't have the time to do so, we will make sure to answer all of them and send them over to you via email as well. We strongly encourage you to ask questions during the session in order to have a meaningful discussion at the end. So without further ado, I will now give the word to Atanas, who will begin his presentation. Naso?
Thank you, Yasen. Thank you. Welcome, everyone. I'll switch off my camera, not to distract you with my nice home, and let you focus on the presentation. So, yeah, I established Ontotext as a semantic web pioneer back in year 2000. We were part of the community which pushed the transition to linked open data and later on to knowledge graphs. While our R&D takes place in Sofia, in Bulgaria, that's a little known country in the southwest of Europe. Most of our clients are essentially multinational corporations, equally spread all over the globe. And yeah, we have the honor to serve some of the most knowledge-intensive enterprises, all the way from BBC and Financial Times and Elsevier on the publishing media side, to quite a number of market intelligence organizations in market intelligence, like Standard & Poor's and Financial Times, to government, NASA, UK Parliament, pharma companies, and so on. So we are part of the evolution of this knowledge graphs trend as member of a number of standardization bodies like Dbpedia. Those are developing the specifications of schema languages, query languages, benchmarks, industry ontologies, if you want, like FIBO. For instance, we are part of the working group at Dbpedia that standardizes currently RDF star, that is RDF extension, which allows metadata richer than the one people can express in other standards like property graphs. Our most popular product is Graphdb, and it's recognized as the most popular RDF, the best RDF engine. We have massive developers community there with tens of thousands of live installations. So for us, the highest priority is for the Graphdb team is reliability and predictable performance. So there are many ways in which you can do shortcuts here and there to score better on a given benchmark, but what really matters to us with this big community and all the enterprise clients and all the thousands of developers is that, yeah, there are no surprises. It may not be the fastest in a specific case, but it's standard compliant and it's predictable. And we are religious about standard compliance because we believe that having full stack of standards and an ecosystem of tools compliant with them is the key for adoption of knowledge graphs in enterprise data management and content management. So our unique offering is that we have both a semantic graph database and text analysis technology. It took us 20 years to get the experience and the infrastructure and the tools to make text analysis and graphs help each other. So we essentially build a platform around Graphdb, which extends its capabilities with text analysis and other infrastructure, so that it can be used efficiently for building knowledge graph-based solutions. Historically, for many years, since the adoption of this technology started, it was a matter of several years and several millions of dollars to build a knowledge graph-based solution, and we are hardly trying to change this and to make it possible and to democratize the usage of this technology to also a much wider set of applications. So to do this, we built a number of knowledge models, we call them, for specific verticals and use cases. So some sort of pre-packaged solutions where you have the ontologies, the schemata, the relevant data sets, the text analysis pipelines, which are already tuned to work with these data sets, so that we can lower the cost of bootstrapping a knowledge graph for a new solution. Because there is always something specific to the specific enterprise, and that's what makes us different from Google, that has a single knowledge graph for everyone. But yeah, we've been mastering how we can lower the cost of developing these tailor-made knowledge graphs, and that's by having ready-made solutions for specific verticals, which we customize for a specific client. So the solutions that we built on top of this platform, they range all the way from tagging and content classification and recommendation to a wide set of applications in site engines and enterprise search and discovery. There are also plenty of clients which are using this technology for data publishing. These are some of the most innovative clients. So we serve quite a number of industries, and we have proven solutions for business cases across several industries that I'll have the chance to talk about later. Jared, can we switch to the next slide? Thank you. I already said that a few words about our positioning, so I'll shorten this up. We gathered the expertise across several technology fields and scientific fields, so you rarely have people who understand text analysis and people who understand how database engines work in one and the same company, but we have a lot of both species. Speaking of verticals, historically we've been very active, and we saw very good early adoption in healthcare, life sciences, publishing, media, government. Recently, in the last 3-5 years, financial services got really active in using this technology. And now for the last couple of years, we see manufacturing and Industry 4.0 picking up. We are less in the business of developing solutions these days because we developed an ecosystem of more than 50 partners. Some of them being consultants and system integrators, and IT services companies, all the way from the biggest ones like Infosys, Fujitsu, Atos, Wipro, Entity Data, to boutique consultants with very high level of expertise with respect to these technology and specific verticals like enterprise knowledge or data language. We also work with quite a number of tool providers which embed our technology, like the database engine, in their tools. These are vendors like Synaptica, Semantic Web Company, Metafacts, and few others. I'm not trying to list them all in order not to forget somebody. So enough about ourselves. Speaking about the market, just to essentially prepare the stage for Jared. Knowledge graphs are in a hype. You see these Gartner hype cycles, in this case, the hype cycle for artificial intelligence, and you see knowledge graphs still being approaching the top and being at the peak of expectations. So we have an interesting 2 or 3 years ahead of us to see which are the applications and the use cases which will survive. And we will try to share with you as much wisdom as we have on the subject, and share with you what is important and what methodologies can make an application of knowledge graphs successful. So to the rest of this webinar, we will first have Jared, who will give you the why and the what. So he'll give you a feeling of what problems knowledge graphs solve, and what is a knowledge graph with some examples. Then we will talk about some use cases, knowledge graphs for enterprises, so specific application use cases in enterprise data management and content management. This will be me. Then Jared will tell you the 10 practical steps, which is our methodology, our wisdom of what it takes to build a knowledge graph and evolve it and use it within enterprises. At the end, I will make a sort of overview of the Autotext platform, which enables which was developed through these use cases and which implements this methodology. So Jared, the floor is yours.
Thank you very much. Hello, everyone. So I am going to talk about knowledge graphs in general. And the first question you always have to ask about technology is, what problems do they solve, right? And I'll start with this quote: is through 2022, the application of graph processing and graph databases will grow at 100% annually to accelerate data preparation and integration and enable more adaptive data science, right? So basically, the myth of centralized control of data is gone, right? Pretty much every organization, more than a mom and pop, is dealing with too much data spread all across the organization, and just the volume is too much of too many varieties. So too diverse, too dispersed, and too much, right? We've all got legacy systems, kind of steam-powered databases in the dusty corners of our basements, when we're trying to get them to play nicely with the existing technology that's coming increasingly fast, right? The time between a new technology and when it's kind of adopted as kind of a general use is just kind of incredible. And you see this recently with Dockers. And then on top of that, there is no system in isolation anymore. I studied computer science, old enough in which networking was one class you took in your sophomore semester. We have internal data and external data, and that too has to play nice. We're in the problem as well is that we have overlap, right? We have different departments within a single organization that have different demands on the same data, and that's leading to replication, repetition of effort, and different views on what the data should be done, right? And so this is the data silo problem, right? We have, if you think about what content meant, you take a piece of data and metadata, content, what content management people are thinking about that, what that is, what the data management versus the knowledge management, right? It's very different tribes dealing with the same data, and we have that issue, right? And we are in the problem now that we as an organizations across, especially content-led organizations, don't know what they know, and we're missing business insights, right? That the speed of which we need to make informed decisions is always increasing, and we're losing those insights because we as an organization, as organizations, don't know what data we have, right? And so we're losing opportunities amongst the silos. Different business units are not talking, they're not sharing data because it's hard, right? And the one example I always think about when I was working in the news industry is instead of dealing with our content management system, the journalists would just go Google the content that the articles they were writing. That was how they found their information. So when Google knows more about your organization than your own organization, that is a business risk, and we need to think about that. So what does it offer, right? Unified data access. A knowledge graph is representing your metadata and your data at a higher level of abstraction. It's representing the data, how it's used, how it's needed, and how it's understood. And that's a really interesting thing. It's about representing data not, specified by the limitations of a relational database. It's about, talking about real world things, and real world things are related to each other. And the data that represents those things in our systems should reflect that. Flexible data integration, this idea that, the schema that you have for this data need not be defined completely in the beginning, a priori, before you need it. You can kind of scale it as you need to, as your system, as your needs grow, as your metadata needs, as new metadata comes in, as our external systems get integrated, you can, the knowledge graph can grow with you. There's a little bit of a click I keep hearing, so I don't know if someone's unmuted. But the exciting thing, and this is really interesting for me coming from a knowledge representation background in the old days, we had these very kind of interesting, and it's possible this kind of utilizing kind of inference to kind of do analytics on the data. But what's really kind of emerging now is this automation of data management and the kind of rich metadata. And the metadata is kind of spread across the organization in various formats, dealing with different types of metadata, right? Structural metadata versus content-related data, semantic metadata. You now have a single representation, and you can start to ask some really complex, interesting questions on your data, right? You can start thinking about the provenance of your content and your metadata and your data. You can say, how did this bit of information get here? What data is where, who needs to see it? You can really start to interrogate some real world questions on your data. And semantics is what gives you that. That's really fascinating to do. So what is this incredible piece of kit that I'm talking about? You already know the knowledge graph, right? So incredibly, in the kind of 15, 20 years ago, Google said they didn't need semantics, that their algorithms were always going to be good enough to be able to kind of answer the queries that you wanted. And then about 15 years ago, they realized that wasn't true. And about 2012, I think it was, Google came out with their knowledge graph, and the company that size doing a complete 180 and kind of representing, to start using semantics. And so every time you're doing a search, there's a semantic search. You have the knowledge graph there. The only problem is it's really nothing you can do with it outside of Google products. There's also Dbpedia, which basically is a knowledge graph that has extracted all the info boxes out of Wikipedia and made a knowledge graph of that. And that's a really powerful thing we've seen in kind of bootstrapping the knowledge bases within organizations. There's no point in you kind of recreating what you already have in terms of, like, there's another one called GeoNames, which is geographical. You can pull that knowledge graph in and make use of that and start to play nice with your own data, referencing the same things. A knowledge graph is a graph, but it's in the thing. So it's our knowledge as humans is not isolated, right? We understand things in its context, and a knowledge graph is mimicking that. So you see the subject verb objects. You have in the diagram there, you see my local cafe is located in New York City. So these are locations, but also you can have a global investment company owns my local graph, right? So my local CAF. So you're creating that network automatically by making the connections between these things and their relationships between the two, right? And that context is very powerful for us, but also for to do inference for automatically, right, through a knowledge through inference and that. The other thing you can think about the knowledge graphs is there's 3 different roles it plays. In this approach, this technology, it's simply a database, right? And just like the database, you can query it. So you can very quickly, so any kind of people who are very comfortable with, you can see how this graph I've shown here can be translated down to, you know, columns and rows, right? So you have Big Bucks Cafes located in Seattle, right? That would be the intersection there. You can do queries. So Sparkle, which is the query language for the knowledge graph that we use because it's represented in RDF, is based on SQL, has a very kind of SQL-ish nature, and you can do that, right? It has schemas like a database as well. Just the other thing is that it's a dynamic, right? The database doesn't have to be defined a priori. It can kind of grow and emerge, but you can it's a database. It's also a graph, and you can do all the things that you do to graphs, right? You can just simply say it's just vertices and labeled edges, and that's it. And you can apply optimizations. You can do operations like traversals and transformations, right? It's just a set, and that expressivity, it's just a set of vertices and edges, and that's quite powerful. But it gets interesting, at least from my perspective, of what you can do when you add that semantics, right? It's also a knowledge base. You have a formal semantics which defines how you can interpret data and infer new facts, and that's the exciting thing, right? And so, for example, and what we have here is you see the little dotted lines is data that isn't explicit in a knowledge graph, but can be inferred through kind of through inference because of the rules that we've set up. And you think how powerful this is in terms of compliance. If you're a corporation about to buy another corporation, you need to make sure you're not falling afoul of any kind of like tax legislation or antitrust legislation. And this is a way of kind of automatically identifying those risks. And that's extremely powerful and interesting. And you're not going to get that from a relational database or a property graph. I'll just do it quickly, kind of just dip down into just kind of the value of semantics and showing a database, right? This is, again, the formal contract, but it's not only kind of sensible to humans, it's sensible to machines. And that's extremely powerful to have a reliable, consistent, precise way to interpret your data. And this is what it gets you. And so ontologies have classes, so people from object-oriented backgrounds will be very comfortable with this and kind of know, you know, you have people, places, organizations, locations. And you can see that in the graph. You see how the kind of the local classes defined in green, and some of the things that we borrowed from established ontologies elsewhere in blue, right? And the relationships that you can create between this. So you have relationship types such as nodes and parents and subsidiaries, but you can also define properties of those relationships, and that's where you can get a lot of power very, very cheaply, right? If you think about defining taxonomies, that ability to have transitivity over properties of, you know, child of and parent of is extremely useful, and that's something you don't have to explicitly do. The machine itself can infer that and add those statements automatically. And of course, categories and topics, something that's much more organic for humans, and very much we have all these. We've spent a lot of years in the kind of using kind of categories and controlled vocabularies and taxonomies, and we have a lot of kind of, you know, knowledge management employees managing those vocabularies, and we can represent those as well. So, and we haven't forgot the humans. There's free text descriptions, and what's interesting that so we can kind of more elucidate what the meaning of these what the statements are. And actually, those also can become a rich resource, especially for the Ontotext approach, when you have this coupling of a language an NLP pipeline to be able to kind of start to mine those to find entities and classes and relationships in those free text searches. This is just a slide to say, don't just take our word for it, and I'll just read it out and kind of move forward. Businesses that do not use a semantic approach are limited in their ability to source, integrate external data, and expose internal data to the same. Leverage semantics to satisfy a conceptual definition of data and enables you to address emerging use cases. Use data models to inform the data without enforcing structure on it, meaning the widest scope of interpretation and the smallest bias towards an implementation strategy. And before I hand it back, I just want to kind of point out that some of you might be familiar with some of these terms, but there are certain things that aren't a knowledge graph, right? So some RDF graphs, you might have this set of statistical data represented in RDF, but where each of the nodes is just a string, right? Italy, GDP at 1.95 trillion. This is missing those semantics. It doesn't have, it's just graphs. All right, sorry, it's just the graph. Then you have knowledge bases. So for example, expert systems with that do have knowledge, built upon like huge kind of arbitrary complex if-then rules and statements, but you're missing the structure of the graph. And it really is the having those two what creates the power of having those kind of triple natured that I said in the first slide about kind of a graph, a database, and a knowledge base. And knowledge graphs aren't necessarily software. It's just a way of organizing data and metadata that can be used by software. And often the software can do multiple of these tasks. It can be a database. It can be reasoned over. It can be used to kind of be indexed, to do full text search, and also kind of editing tools. You see those pretty kind of nodes and arcs, editing those that are manipulating the RDF under the hood. And just one more slide, I'm just kind of talking about the difference between kind of property graphs and RDF, and I'll go very quickly. It's not just a pretty graph, it's really about those semantics, right? And knowledge graphs were designed with a interoperability at a web scale. This is what we're talking about. It's built on open standards, so there's no vendor lock-in, but without those semantics, you're missing a lot of the kind of power. And often what happens is developers understand JSON and understand property graphs and go straight to that, and they start to try to see that actually the functionality of them and putting those semantics and using schemas is very useful, and they start kind of home brewing what already exists. These standards are well defined and they're out there. You see RDF stars in development, RDF, OWL, Sparkle, these all exist. You can see them on the W3 page, and it creates that kind of interoperability, federation across multiple databases, which is a godsend, provenance, inference, and constraint management. And with that, I will pass on back to Naso to continue on about knowledge graphs kind of in the wild and kind of enterprise strength. Naso?
Thank you, Jared. Okay, so yeah, I'll try to make some bridges between these new paradigm and new trend with the knowledge graphs and what's already known in the enterprise data management space, because in fact these platforms, they combine capabilities which we perform tasks which we already know from some mainstream systems. So quite a good amount of the applications of knowledge graph that we have seen are actually about master data management, reference data management. So it's about pulling together more extensive than usual collections of, if you want, information about companies or information about people, information about products. So that's everything that the classical master data management is about. But now, there are new ways of doing it, and there are benefits of doing master data management with knowledge graphs. It's mostly about being able to quickly integrate external data sets with the master data that you have to manage yourself. Knowledge graphs are also a lot about metadata management. So they were created as a standard for describing web pages and resources on the World Wide Web. So they have very high expressive power, and they are really good to to accommodate different types of metadata. So they definitely cover quite a lot of the functionalities that people are used to with metadata management. Many people can interpret and tell you that knowledge graphs are nothing more than taxonomy on steroids, and that's right to the extent to which you can make a much better taxonomy just by expressing it using one of these graph formalisms and then putting formal semantics to it and enabling higher level of interconnectivity between different concepts in this taxonomy, so that it's not just a hierarchy but actually a much more structured resource and interrelated resource like Wikipedia, which is again I'm using the example that Jared gave with Dbpedia. That's essentially Wikipedia in a graph. You can think of it like a taxonomy that has 5 million concepts in it, which have degree of connections between them that is on average higher than 5, and that's unprecedented for a typical enterprise ontology. So yes, knowledge graphs can be seen as taxonomy on steroids, and in most of the applications that we see and the best practices is that in most of the knowledge graphs you would have some sort of controlled vocabulary or taxonomy as part of it. Knowledge graphs are very often used if you come from the data management community and data integration. Then there is a lot of the work that people usually do with data warehouses and data lakes, which can be done in a more efficient way with knowledge graphs. It's not for free. There is a lot of work to be done on data integration, harmonization, cleaning, record linking if you want, but there are certain benefits of doing these data management jobs as part of a knowledge graph platform. At the end of the day, such systems very often end up being used for enterprise search, or call it discovery, call it insight engines. So everything that is too complex to be dealt with by pure full text search and requires more powerful search instruments. So that is a very, very typical use case for knowledge graph systems. Finally, if you are a data scientist, essentially knowledge graphs can be seen as something that gives you just a better way of doing data management for analytics. So setting the ground for augmented analytics by doing better job in data preparation, data cleaning, providing more data which are not just tables but rather interlinked elements, networks, which enable a richer set of analytics, not just what we can do with a table, but also graph analytics, graph embeddings as complement to this arsenal that most of the data scientists are used with. So all this is recently there is one emerging term called data fabric, which is quite a lot about new ways of doing data integration. And if you are interested in data fabric without the plural, then it would be interesting for you to explore what is the role of knowledge graphs in it. And it's mostly about managing all different types of metadata that you need for data fabric to work and to provide these more flexible mechanisms for data integration. So let's summarize what are the main use cases for knowledge graphs, the typical applications. We've seen many publishers, and our customers include many of the leading scientific technology management publishers, and medicine publishers like Elsevier or Oxford University Press and Wiley. Many of these people use knowledge graphs for content enrichment, so to generate richer metadata describing their precious content so that they can better repackage it, repurpose it, resell it, and at the end of the day monetize the content better. Then another use case is, as I mentioned, let's call it semantic search. And I have a more concrete example on the next slide, but it's again about discovering information when you need something more advanced than full text search or than a typical database query. Third use case is recommendation engines. So particularly when it comes to personalized recommendations, of course, this is something that you can do without graphs, but graphs help. For instance, one of our big clients is Financial Times. We help them make very, very extensive knowledge graph and linked data platform. And one of the interesting use cases is that they use it for personalized recommendations. So if you have an ft.com account and you go through, you read an article, underneath the article there are recommended reads. So these are personalized recommendations which are based on your reading history, your profile, and the semantics, the meaning, the content of the article that you're currently reading. So they benchmark the performance of mainstream recommendation systems, and if you are Financial Times, you have access to the best vendors, and they compared it to personalized recommendation that we built using knowledge graphs without being so highly specialized in personalized recommendation. And the knowledge graph based systems scored much better. So this is a very good use case for all the way from people who sell content, media and publishers, to also e-commerce applications. And then the last use case is essentially the basics. So that's when you build a knowledge graph for the sake of building knowledge graph. That's for the sake of having a data platform that will be used for a set of other applications. But the goal of a specific project could be just building a linked data platform, or nowadays you would call it data fabric, or some data integration platform that allows you to do better master data management, or to improve your capabilities to deal with continuously changing data and do continuous data ops, maintaining the quality of the data, and so on and so forth. So this is a brief summary of the most typical use cases in terms of applications that we've seen. And just to give you a more concrete view on one of them. So one of our big clients is AstraZeneca, one of the biggest pharma companies. And they've been in trouble because they have thousands of studies, clinical studies of drugs. So to help you get an impression of it, each clinical study report is a PDF of several hundred pages each. So their task was, their problem was that when they get an inquiry from FDA or from another regulator about side effects of a specific drug, they needed as much as 3 person-months to figure out which are the clinical studies which are relevant to this inquiry, so that someone can sit down and write the answer. With the knowledge graph-based system that we built for them, we reduced this time from several months to a couple of days, just for the pre-selection of these clinical trial studies which are relevant to this inquiry. So at the end of the day, the application was search. It was just, we delivered something that does better working search. But underneath, it was a matter of integrating several different databases and sources, both proprietary within AstraZeneca and public data sets, of which you have plenty in the life sciences. and then developing very high precision text analysis pipeline, which can analyze these documents, analyze the sections, and do a really high accuracy text analysis to figure out which concepts are mentioned in what context, so that you can do really advanced search on top of it. So the final result is 100 times more efficient search, but underneath you had 1 year building really comprehensive knowledge graph with billions of life sciences entities as part of it and thousands of big documents being processed. Enough about this use case. It's good time to pass over to Jared to walk you through our methodology for building and evolving knowledge graphs.
Right. Thank you, Naso. So every organization is different, but Ontotext is working on a second decade of seeing these different. They've gone through this enough times, through enough verticals, so kind of understand and kind of distill down the kind of general steps. So I'm going to step you through that very quickly, so we make sure we have time for questions afterwards. So number one is clarify your business and expert requirements, right? This is establishing the goal behind collecting the data and define what questions you want to get answered, right? And again, this is something that's kind of done usually with kind of Autotext consultants and partners, kind of advising you. They've seen what's possible, where the technology performs the best, what other kind of existing technologies can be brought in, what other databases, what data sets can be marshaled. Then two is gather and analyze relevant data, right? This is discovering what data sets, taxonomies, controlled vocabularies, and other information. This could be internal, this could be external, these could be proprietary, these could be open or commercially available, right? And you want these to serve, which ones of these are going to be the best to serve your goals in terms of domain, scope, provenance, and maintenance. And the nice thing about this is you can kind of have your nice to haves, you kind of focus on those, on the kind of like mission critical ones first, right? Oops, sorry. Step three is clean your data, ensure data quality, right? This correct any data quality issues to make sure that the data is most applicable to your task. And this includes removing invalid, meaningless entries, adjusting data fields to accommodate multiple values, fixing inconsistencies, etc. Step four, create your semantic data model. Now we're starting to get into the fun bits. This is analyze thoroughly the different data schemas to prepare and for harmonizing your data. This is you reusing things that are kind of out there and open and defined. These are engineering your own, probably a combination of both, right? Adapting what's out there to your specific requirements. This is looking at kind of application profiles, RDF shapes, or some other mechanism and how to use all these things together. You formalize your data model using standards like RDF, right, and or OWL. Step five, integrate data with ETL or virtualization, right? So this is where you're applying your extract, transform, load tools to convert your data to RDF, right? We're starting to harmonize things, we're starting to get things looking like. You can use data virtualization to access it via technologies such as NoETL, OBDA, GraphQL federation, etc. Generating the semantic metadata that's going to be easier to update, discover, and reuse, right? We're starting to have that lovely higher level of abstraction, that higher level of understanding of your own data and metadata and content. Step six, harmonize data via reconciliation, fusion, and alignment. This is matching descriptions of one or the same entities across data sets with the overlapping scope and handle their attributes to merge the information.
Yeah, Jared, can I just make an example for this one, because that's my favorite, the step six. So a concrete example of one of our big clients was, it was a investment bank, investment advisor. So it's, can you switch back to step six? Thank you.
Yep.
So they wanted to have a better view on the market of mergers and acquisitions, and they were rich enough to have access to all the databases that you can buy in this field, all the way from Capital IQ to Thomson Reuters stuff to Dow Jones to Crunchbase and everything else. And they've been in big trouble because putting together and integrating this data and doing the linking between the all the information that's about a specific company in one of them and information that's about the same company in the other database. It's not trivial at all, because you have one database with 5 million companies, and then you have another one with 1 million companies, and then you have 4 more databases. So the data integration, the data linking task is just enormous. And that's what you have to do to figure out that IBM over here is the same IBM over there. And then I should find a way to fuse the information from 2 databases in a way that brings a consistent data set, a consistent graph. So that's probably the heaviest task after all this prep work, being able to reconcile and put together in a meaningful way information from different sources. Sorry for interrupting you.
No, good example. Number 7. This is when we start loading things into the Graphdb. So it's, to me, this is getting even more fun. So this is putting all the different graphs into Graphdb itself, which is kind of the RDF database at the core of the Autotext platform that Nassau will be talking about in a minute. And, for kind of local graphs, Graphdb is more than capable of kind of, enforcing the semantics via reasoning, consistent checking, and validations, but scaling is not an issue in terms of kind of scaling in a cluster and synchronizing with search engines like Elasticsearch. Number 8 is augmenting the graph via reasoning and analytics and text analysis. To me, this is where the fun bit happens. And this is really starting to extract new entities and relationships. You're really starting to get the machine to kind of think about this thing as if it was in, these things as in a real world, right? And it's about, pulling in semantic metadata from unstructured documents, interlink mentions of concepts, and the more interconnected, the better it gets. And as kind of more information gets in, the graph itself kind of builds and builds and builds until you're inferring new facts, discovering new relationships, patterns, while always maintaining that traceable provenance, right? So you can find out where all this stuff came from. Step 9 is maximize the usability of your data. This is starting to deliver the answers that you wanted to have in the first place. This is creating different knowledge discovery tools. So if you have somebody who's creating kind of very complex, arbitrarily and complex and complicated Sparkle queries to really get into some really interesting insights, but also much more easy to use GraphQL interfaces, semantic search, faceted search, data visualization, it's all there. And now your data is that fair, accessible, interoperable, and reusable, the fair that we're looking for. And then finally, you've done the work. Now, as it kind of evolves and maintains, it becomes much easier, right? Finally, as you crafted your knowledge graph and people have started using it, you can keep it live by setting up those maintenance procedures, some of them automated. The way you can evolve and update from different sources that are being consumed to maintain that high quality that you've just created with the knowledge base. And finally, the last section is going to be about the Ontotext platform that helps you do all that. Nassau?
Thank you. So it's just sharing what we came to, and we are currently in third version of this platform. So we had our first sort of knowledge graph platform. It wasn't called this way back in 2005, 2006. So we've been able to put together background knowledge information in an RDF database 15 years ago. And I have information about all the popular entities on Earth, and use this information to analyze news and analyze millions of news articles and do all sorts of semantics tricks. So, and ever since 2005, we've been maturing this platform and finding better ways of do the software architecture and organize all the processes. So that's where we are. So the basic thing that this technology allows you is to synergize what was usually disconnected communities and disconnected systems: data management, knowledge management, content management, and analytics, data sciences. So that's the ultimate goal of providing a playground and providing a platform that can serve well all these communities. And On the one hand, there are all sorts of facilities related to data integration, data linking, sourcing data from existing systems, and defining what the data schema should be, and how the database should be configured to serve specific purpose. And that's the work of enterprise architects, data architects, software architects, and data ops people. Then there are separate set of tools and functionality for people who care about content, be it authors or editors or people who professionally work on curation of some content. So there is all the automation that helps enrich content, but also do the links between structured data and content. And that's what we call semantic annotations or semantic metadata. A set of tags that essentially provide references from the content to the relevant concepts in the graph, in the knowledge graph, in the structured data sources. So semantic metadata puts together data and content. And given this semantic data model, which consists of ontologies that we use as schema and taxonomies that we use to better index content, for instance, we end up with a very rich, multifaceted structure, this knowledge graph in the middle that can serve multiple purposes. And now the question is what it takes to use this knowledge graph, because you end up with a graph structure which keeps provenance. It is quite rich because it accommodates data from different sources. It has really complex, sometimes recursively nested metadata that is metadata about some schema or something else. So it can get really complex. And what we found through the years is that this could be really hard to use for the application developers who have to do something with this system. So one specific thing that we did was that we introduced the so-called semantic business objects, which allow business analysts or subject matter experts define specific views, partial views to this knowledge graph, which are tailor-made for specific applications, so that application developers don't get lost in the big knowledge graph. So the technology that we provide there is essentially generating GraphQL interfaces on the basis of these semantic objects. And the fourth type of actors and users are data scientists, which in many cases they are the main user of this knowledge graph structure, taking this ultimate data source and unified data resource and use it for analytics, either to train specific classification models or prediction models, or to simply export this data and make it accessible to downstream systems like business intelligence systems or data analytics. So that's the big picture. And again, the beauty is how we can put together all these different stakeholders. Here you see a short list of it's not short, it's 6 things in it. Different types of reasoning capabilities and analytic capabilities that the platform provides. So that's the logical inference, that what we saw with the dotted arrows when Jared was telling you what is a knowledge graph, and that's just about being able to follow transitive relationship, like control relationships between companies and their subsidiaries, or to traverse nesting of geographic locations or category hierarchies and this kind of thing. Then we have text analytics, that's all about extracting, recognizing concepts and entities when they're mentioned in text, so that you can do automatic tagging or extraction of new elements. Graph analytics is what makes the big difference between a normal database and a knowledge graph. and it's that you can do things like PageRank to figure out which are the most important nodes, so that you can use this as further evidence for disambiguation, or to make better recommendations, or even for autocomplete when somebody is searching. Geospatial is there just because it's needed, and it combines well with some other features, being able to apply like constraints like nearby, find airports which are within 50 miles of New York or whatever. You need specific indices. That's part of the system. Also, full text search is a must in pretty much every application that we've seen. And the most recent addition to these capabilities is the so-called Semantic Similarity. So it's a library embedded in Graphdb that allows you to use word embedding and graph embedding for, let's call it statistic inference. So the beauty of the platform is that you can use any combination of these analytic services from Sparkle, or if Sparkle that includes all these different types of things is too complex, someone can wrap it as GraphQL that's really easy to consume by the applications. So that's the last thing that I'll get very specific about. The interplay between text analysis and graph databases, particularly GraphDB. We've been doing text analysis since the very beginning. That's why I called the company Ontotext. And we have the standard weaponry, like in each and every natural language processing technology. So you have a pipeline of different stages of processing, all the way from language detection through part of speech analysis through whatever else, to get to the final result. So one important component in such pipelines is the so-called gazetteer. So that's a component which can recognize names of known things when they're mentioned in text. One special integration point is that in our text analysis pipelines, they can load these names of things directly from the database engine and get updated when they get updated in the knowledge graph. This may not sound as a big deal, but if you have hundreds of millions of entities that you deal with, that's not trivial from an engineering point of view. What is the most complex task in such named entity recognition pipelines is disambiguation, because if you work with a big vocabulary, if you work with a big knowledge graph, like what we do in most of our projects, you get a lot of ambiguity. So when you see Paris in text, you are never certain whether that's Paris, the capital of France, or it's Paris in Texas, or it is Paris Hilton. So this is a task that the person who reads the sentence very quickly picks up which one you mean by the context, and that's extremely hard for computers. So that's where most of the free text analysis pipelines fail. And to do this better, and we won many awards this way, we use entity profiles, entity fingerprints that we derive from the graph, and we use the context that you can distill from the knowledge graph about each and every entity based on the connections to the other entities. And this helps us do much better disambiguation. The way text analysis and graph databases do the tango and do the steps and help each other is that once you are done with this text analysis pipeline, you actually generate pieces of metadata, new facts and new entities that could be added to the knowledge graph and be useful for the analytics. Okay, so it's good time to finish. We can skip this one. We already mentioned it. Here you see, some diagram that shows to what extent this Ontotext platform and Graphdb are open to for access to external tools, open for customizations, like you can build custom connectors or custom analytics plugins in Graphdb. You can connect different tools. You can connect via Sparkle. But if you are want to access the data from a legacy knowledge graph, you can legacy tool, you can access it also via SQL to the JDBC driver, and so on and so forth. So it's a highly customizable architecture. There are plenty of open source components in it, like the entire workbench of Graphdb is open source. The plugin APIs for Graphdb are open source. There are quite a number of plugins which are open source, like RDF-Rank, which is PageRank for big knowledge graphs. It is open source, so everyone can take it and fork it and do whatever analytics you care about. So with this, I want to finish this overview of the platform and Graphdb, and open the floor for some questions.
Thank you, Nasser.
You can switch to the next slide so that it's on the screen while we are answering questions. Jared, because that's the slide which shows the set of different requirements that we can cover with the platform. I hope Jared is okay. But yeah. Anyway, let's go and get some questions for those people which were patient enough to stay with us for a full hour. Okay, the first question is from Abid Ali Faridi. How knowledge graph can handle mixed data for accessibility is concerned? Well, I can't really get this question quite well. The basics is that there is no free lunch, so knowledge graph doesn't make this automatically. It always requires specific attention to integrate and to transform a specific piece of content or specific piece of structured data. But this knowledge graph technology makes this easier. Let me scroll down through the other questions. Graphdb are used in underlying storage in many leading metadata management tools. Does Ontotext position itself against these tools as an independent platform? Wow, that's a very good question. No, we are not that stupid. So there are quite a number of areas in which we basically don't offer any tools which Ontotext develops. One example is ontology and vocabulary editors. So we work with most of the leading providers of taxonomies and ontology editors, and that's something that Ontotext doesn't do itself, but you have a choice of a number of different tools that you can work with. So that's very straightforward, and the reason for this is that there is no single way of doing a vocabulary management tool that's good for everyone. So different use cases require different tools, and we let our partners find their niches and work there. How do you integrate a knowledge graph with Lucine Solar inverted indices? Enterprise search. Okay, so well, we figured out many years ago, probably as much as 10 years ago, that for specific workloads, it's better to use these search engines rather than try to make them inside the graph database. So, and a good example for this is obviously, okay, the plain search, but also if you want to do faceted search, the indices of Lucine and Elastic and Solar are precisely what you need, and you can't beat that essentially. So what we did was we have so-called connectors, so you can see them in the lower left part. these are essentially there are two types of plugins in Graphdb. One of them is the connectors, which include full text search connectors, and the other type is analytical plugins. So the connectors essentially allow you to build different full text indices on the graph. So you can specify, I want an index that that covers only these type of entities that I have in the graph, for instance, people. And I only care about these specific properties of these class of entities, or these property chains, or I want to filter out this and that. So you have the full power to customize and to say what kind of information you want in a specific full text search index. You can have as many of those as you want and use them from within a Sparkle query together with structured constraints. These full text indices are automatically updated upon transaction commit. So each time when you change something in the graph, say you add a new company or a new news article, when the transaction is committed, all the connectors which deal with information like the one which was updated will take care to check, is there something that has to be updated in the full text search indices. So the updates of the indices happens transparently for the developers. Yeah, let's see some other questions. Oh, Jared, you're back. Did you have any troubles with the connection?
No,
okay.
he's still offline. So I'm trying to get him just switch aside.
Jared was lucky enough to move from UK to France recently, and yeah, he's still settling, and connection is far from perfect. So I thank him. He joined us. Okay, I'm just scrolling through the questions. Can you support enterprise semantic search with facets on structured? Sorry, just to move the questions pane a bit, on structured and semi-structured data without Solr inverted indices. Well, yes, we can. I mean, my PhD that I dropped out of is actually about information retrieval and search. So we had our own implementation of all the machinery you need for full text search, including the inverted indices and everything else. But it's not worth the effort. So Lucine and Solr and Elastic do a very good job. So it's much better to integrate with them. So yes, and I think we have seen your emails. Or that's Jared, doesn't matter. Okay, let's go to see what other questions we have. So we have a question from David Grossfeld. To what extent do you find the more esoteric OW constructs like cardinalities, restrictions, functional properties, and so on used in real life? Do subject matter experts struggle with these concepts and stick to simple is, are, and subclass relationships? That's a very good question. In the 90s, I was teaching reasoning and ontologies in the university, and yeah, I find, for instance, description logics really amusing. So it was a very good intellectual exercise to figure out how it works and to be able to work with this logic and to create ontologies that use it. And then, getting older, I figured out that, well, that's very, very hard to do in practice. So once you go beyond a specific size, using expressive logic to make a big ontology makes it really hard to maintain and to understand and to debug and to predict what comes out of it. So my short answer is that most of our clients use relatively simple ontology primitives and ontology constructs. So speaking of OWL, we find most useful OWL to RRL. So that's the fragment of OWL, that the language profile that can be supported via rules. So it has very little support about cardinality and other constructs that are both complex for human to trace at a big scale and computationally expensive. So what we get as default reasoning setting in Graphdb is a rule set called RDFS plus, which has support for subclass, subproperty, well, domain range, everything that you have in RDFS anyway, plus symmetric, inverse, and transitive relationships. And that's what we see most of the projects, which are like real-world systems with operations requirements and data quality requirements use. So I saw very few people using something more than this in a big production system. So we probably have time for one or two other questions. Is it possible to have a CCAN server integrated with the Autotext platform? If yes, what will be the distribution of responsibilities among the different parts? That's a question by Jean Gigo. Excuse me if I don't pronounce it right. Well, at a very high level, you can think of a CCAN server as a linked open data catalog. So yes, you can have integration between these systems in CCAN and a triple store like Graphdb, in the same way in which you'd integrate it with data catalog system like the one of data.world, for instance. So the distribution of labor is that for most of the work that you do in this kind of system, you don't need a highly scalable database engine. So once you start provisioning the data and you start taking care of hosting data and be able to take samples of data sets and do something with it, that's where you need Graphdb. But for the cataloging aspect of these services, let's be fair, you don't really need it. Okay, so there is a question by Daniel Bacchus. How do you solve the challenge of considering dimensional and contextual perspectives in linked data? Many entities may be perceived differently or have different properties and values through time, or depending on the location they are viewed from. This is all a dimensional perspective in spatial or temporal. And also the contextual perspective, like how different social, economic, artistic, etc. contexts can be defined the way an entity is perceived. Well, obviously there is no easy answer of handling different contexts. My favorite AI projects from the 90s is Psych. So Doug Leonard and the team, they were trying to build a gigantic knowledge base modeling the knowledge of a 7-year-old kid. So to provide basic intelligence for software systems. And by doing this gigantic universal knowledge base, they had to deal with context. precisely for this reason, that depending on different domains or historical or spatial perspective, things can look very different. And I ended up with 19 different dimensions of context. So whatever you say for each single micro theory or component, or even for a single statement, you had to specify in which context it is true. So on the bigger picture, that's very complex. And if you want to do all of this with all the complexity that you can hypothetically think of, it's getting very expensive, both to do the modeling and to do the processing of data with such a complex considerations about context. So most of the systems have very limited notions of context. RDF allows you to deal with context in the most basic mechanism is that you can deal with named graphs. So actually all graph databases that use RDF nowadays support not triples but quadruples. So you essentially each time when you have a statement like subject, predicate, object, you have a fourth element that is context, so that you can you can put there an identifier of a context, and then you can have a separate element in the graph which is the description of this context, so that you can make arbitrarily complex statements about this context and describe any of these dimensions that you care about. So RDF is unique for the fact that you can put together your data schema, like what Jared was demonstrating with this class hierarchy of woman, person, agent, and relationships, and so on and so forth. And you can have in the very same graph structure the instances, and you can have in the very same graph structure also the descriptions of the context. So you can describe themselves with the very same powerful graph language, so that you can model all dimensions that you care about. So Grafana link in the presentation doesn't work. That's a question from Tanuya Gupta. We'll look at it and send you back a correct link. So I think 17 minutes past the hour is a good time to stop. Yasen, do you have any final words? Are we missing something, or we can close the session?
I think we can wrap it up. Thank you, Naso.
Yeah, I just wanted to mention that essentially most of the content of this presentation and actually much more is we have it in a white paper that we developed with Jared. So stay tuned. It will be published sometime during November, so you can get a more consistent paper which covers the very same subjects. Thank you very much for your attention.
Yes, thank you very much, and have a nice evening or day, whatever. Bye bye.
Bye bye.